Hello everyone, welcome you all to this new module in year 18 Math 41, which is complex analysis, probability and statistical methods. So here we are going to discuss about the module 4 according to your syllabus, and the title of the module 4 is curve fitting and statistical methods. As a part 1, we are going to learn the statistical methods first, and then we will be studying the curve fitting part. So in statistical methods, today in this session, we are going to learn about the review of basic concepts of statistics and a little bit about the correlation. So when I say review of a basic concepts, so it is very important to recall what and all you know about the statistics. So what do you know about the statistics? So statistics is a discipline of a mathematics which concerns the collection, organization, analyzing, interpreting and presentation of the data. So this applying statistics to a scientific, industrial and social problem, it is very conventional to begin with a statistical population. So what this population can be a diverse group of people or objects, such as all people living in one country can be one part of the population which we consider. Likewise, every atom composing a crystal can also be another category of population. Likewise, statistics deals with every aspect of data, including planning of the data, collection in terms of design and survey of the experiments. So according to this paragraph, the survey of the experiments are whatever the survey that has been done the surveys, the output, in order to calculate the output, the statistical methods can be used, and even the experiments also use the concept of statistics. So histogram of the flow of data. So the data, whatever has been given, can be represented in the form of a graph like this. So it will have one minimum point, one maximum point, and one the middle point or the peak point. So whatever the data we have, whatever the data we collect, it should be in the form of a normal distribution. So it must have all the categories: minimum point, maximum point, middle point, and other things. So now there are few definitions which we have to recall. One is measure of central tendency. As the name itself indicates, center point. So if there is a group, you be the center of attraction. It means attracting person in a set of people. Likewise, an attracting point in the center of in the set of data. So what is the attraction there? So if we can understand that center point, then it is able to roughly guess what should be the values at the data given for us. So likewise, a frequency distribution, in general, it is a group of the data around some central value. So finding this central value, the average will give the measure of central tendency. The measure of central tendency gives us the rough idea where the data points are centered, upon which the data has been built. Like that, we will be able to understand. Another definition which you have to know was the mean. So here we are going to discuss about the arithmetic mean. So let us see that x1, x2 and so on up to xn are the set of n values of a variable. Then the mean value is going to be represented as x bar, and it is defined as x1 plus x2 plus and so on up to xn divided by n. So where x1, x2, x3 and so on up to xn can be written as summation I is equal to 1 to n xi divided by n. For the frequency distribution, mean can be calculated as f1 x1 plus f2 x2 plus and so on plus fn xn divided by n. So this formula can also be written by using the sigma expansion like this. So that is the mean. The definition, another definition which we have to know was the median. So median is going to be defined as L plus n by 2 minus c divided by f into h. What is L here? L is the lower limit of the median class, n is the total frequency, f is the width of the median class, and c is the cumulative frequency up to the class preceding the median class. So next definition which you have to know is the mode. It is defined as the value of a variable which occurs most frequently. There will be a value of a variable which is occurring again and again. You can see that value again and again for the same variable. Such value is called as the mode. So mode can be defined as 3 times of mean minus median. Our mode is L plus delta 1 by delta 1 plus delta 2. So next let us see the geometric mean. So let us consider the same set of values which we have considered while defining the arithmetic mean. x1, x2 and so on up to xn are the set of n observations. Then the geometric mean is given by, geometric mean is represented as gm and it is defined as x1, x2 and so on up to xn, the entire thing to the power of 1 by n. So when we take the log on both the sides, by using the property of logarithm, log x to the power of m can be written as m log x. So with that, this 1 by n, log of this bracket to the power of 1 by n can be written as 1 by n into log of this entire thing. Now, for a frequency distribution, geometric mean can be represented as x1 to the power of f1, x2 to the power of f2 and so on, xn to the power of fn whole to the power of 1 by n. So log, when we take the log on both the sides, log of geometric mean is 1 by n into f1 log x1 plus f2 log x2 and so on, fn log xn. So now let us define the harmonic mean. The harmonic mean is x1, x2 and so on up to xn are the set of n observations. So n values of data which has been given. Then the harmonic mean is defined as, it is the reciprocal of arithmetic mean of reciprocal of the quantities. Arithmetic mean, reciprocal of the arithmetic mean, and reciprocal of which is the harmonic analysis, harmonic mean. So which is 1 divided by 1 by n into 1 by x1 plus 1 by x2 plus and so on 1 by xn. Same thing for the frequency distribution. It is 1 divided by 1 by n into f1 by x1 plus f2 by x2 plus and so on fn by xn. So one more definition let us recall here is measure of measure of dispersion. So dispersion is the degree of scatterness. Dispersion, dispersed, the values are dispersed, the people are dispersed, means they have moved away. So degree of scatterness is called as the dispersion. R, it is also defined as variation of variables about a central value. Next is the range. The range is the simplest method of dispersion and is given by the difference between the largest value and the least value. So range is the subtraction or the difference between the maximum value and the minimum value. Next is quartile deviation or semi-interquartile range. Semi-inter or quartile. So quarter means we are going to take it as 1/4 of the circle is called as the quarter part. So quartile here is called dividing the frequency into 4 equal parts. Dividing the frequency into 4 equal parts. So if for an example, if Q1 and Q3 are the first and third quartiles, then semi-interquartile range Q is defined as 1 by 2 into Q3 minus Q1. So all these definitions are very, very important. You have to remember them. The next one is mean of deviation. The mean of deviation is the mean of absolute difference of the values from the mean, median or mode. The mean deviation is the mean of absolute difference of the values from the mean, median or mode. So mean deviation can be represented as MD, which is defined as 1 by n summation fi into xi minus a, where a is either the mean or median or it can be the mode also. So all these definitions what you are learning, once we start using in the problem, you will understand them in a better way. So hope you have already studied all these things in your earlier classes. This is only the recalling session that we are doing it here. Let us discuss about the standard deviation. It is the powerful measure or it is an important measure of dispersion is the standard deviation. Standard deviation is represented as SD, which is defined as square root of 1 by n summation fi into x1 minus x bar the whole square, when n is the total frequency. So standard deviation here is equal to square root of summation fi into di by n minus summation fi into di by n, entire thing the whole square. So next is variance. So variance is, straight away you can write square of the standard deviation is variance. Square of the standard deviation is variance. So that there are all other basics definitions are basics of the statistics, which you must know. So now let us see what is correlation. Correlation has been discussed in this module particularly. So correlation, the word itself says correlation. Co is together. So there are two variables x and y. So the change in one affects the change in the other. So they both will change together. So x also changes, y also changes. So whatever may be the change, but the change will happen. That is how we say both the variables are related to each other. That, in other words, we call it as correlation. So if the change in one variable affects the change in the other variable, then those two variables are called as correlated. So what are the types of correlation? So there are types of correlation which we can see. One is positive correlation and the other one is negative correlation. So if increase in one variable or decrease in the one variable or decrease in the value of one variable corresponds to, so here it is increase, here it is increase, and here it is decrease. So increase in one variable leads to increase in the other variable. Similarly, increase in decrease in one variable leads to decrease in the other variable. So if both the variables are in the same direction, either in the increasing direction or in the decreasing direction, then such a correlation is called as positive correlation. Similarly, if increase or decrease in one value leads to decrease or increase, so you can observe increase or decrease leads to decrease or increase. So when there is an increment in a value of x, if y decreases, it is in the opposite direction. Similarly, if x decreases and y increases, they are in the opposite direction. Such a correlation is called as the negative correlation. So few such examples for this type of correlation is height and weight, yield of a crop are positively correlated. So you may also tell, as in the COVID period, we started using the data, the mobile data, internet data, like most of the people started using it and usage has increased. Meanwhile, the cost of the data also increased. So we say the data, internet data and the cost have the positively correlated. So to give an example for a negative correlation, as the mobile usage increases, the battery in the mobile is going to be decreased. So that is an example for a negative correlation. So in this way we can define the positive and negative correlation. So you can also give a number of examples in that way. So simple and multiple correlation is another way. So here when only two variables are studied, we say it is a simple correlation. If the relation has been studied more than two variables, then it is a multiple correlation. So when there is only two variables are considered, it is simple, and if there are more than two variables, then it is going to be multiple correlation. So a best example for a simple correlation is demand and price. As the demand increases, price also increases. As volume increases, the pressure increases. So volume and pressure are studied together. So there are only two categories we have considered. Therefore, it is simple variation, simple correlation. When more than two variables studied, we call it as a multiple correlation. So for example, price, demand and supply. These are the three things which we are considering at a time. So such correlation is called as the multiple correlation. So types of correlation can be linear and non-linear also. So when do we say correlation is linear? If the ratio of a change between two variables is uniform. So we also discussed change in one leads to change in the other. Increase in one leads to increase in other, or increase in one leads to decrease in other. Likewise, the ratio of a change, the percentage of change, the amount of change between the variables is uniform. Then we say that is a linear correlation. If the ratio among the variables is non-uniform, then we say it is a non-linear correlation. The another one is perfect correlation. The ratio between the two variables is constant throughout. Then such a correlation is called as perfect correlation. So this is about the concepts of correlation as well as the basic concepts of statistics. So I guess you all have studied these things except correlation part. So try to remember all these things so that you can solve the problems in a better way. So thank you all.